All right, welcome to another past question paper, and this is February 2017. Question 6. Okay. Okay. Let's bring it back again. Yeah, that's better. It's bigger now. Okay. So we have two graphs, the graph of F and the graph of G. The sketch shows the graphs of functions f and g. The functions f and g are defined by these following equations, respectively. The constants c and k are positive. The point pi over 6, 2 lies on the graph of f. Okay, that is going to be important, I think. Use the sketch to answer the following. For the function f, determine the period. Okay, so must determine the period for which function, or for this one. And this is a tangent graph. Tangent, ne? Yeah, that is a tangent graph. So what do we know about a tangent graph? A tangent graph, in standard form, it will be tangent graph will look like this. That's so that's how a tangent graph will look. Okay, in standard form. All right. Now, okay. This is just one complete period. So the period is the distance from here to there. So from asymptote to asymptote. All right. So let's find the period for this one. Let's take so from asymptote to asymptote, right? Let's take this asymptote, 5 pi over 3 minus pi. Let's see what we get. 5 pi over 3 minus pi. 5 pi over 3 minus 3 pi over 3. 3 pi over 3 is pi. So 5 pi. Okay, 5 minus 3 is 2 pi. So this is the period. Okay, this is the period. Now let's see. It's 6.1 A. Period is 2 pi over 3. Okay. The value of C. So the value of C, okay, it has to do with the period. Okay. So remember that we said that the period for all the other graphs, the sine, cosine, secant, and cosecant. Cosecant. These four, they have a period of 2 pi. Okay, but for tangent, and cotangent, the period is different. It is no longer 2 pi, but it is pi. Okay, so meaning that now we have to say period is equal to pi over 2 instead of saying 2 pi over 2. Now, since we know the period, no man, not over 2, but over, is it K or what? Let's, oh, it's C. Okay, over C. C is the variable, is the number next to X, actually. So P, we know period. The period is 2 pi over 3. Okay, so let's substitute 2 pi over 3 for period. Equal to pi over C. Let's cross multiply. We find that 2 pi C is equal to 3 pi. And if you divide by 2 pi, then the pi's will cancel. And you find that C is equal to 3 over 2. Okay. So B, C is equal to 3 over 2. Okay. C, the value of P, and that's okay. So the value of P. Where is P? No. We're looking at the wrong. Is it? Yes, we are. The value of P. Okay. So P is this one right here, right? Okay. Now I know the value of C. Okay. I can use this point. You remember the point I said is going to be important. The point as my Y and X. As my Y and X to solve for P. Let's do that. So they gave us, let's work it out on the side here. So they gave us this equation. P tangent what? Cx. Alright. Now I'm saying we're going to use the point that they gave us as pi over 6, 2. We're going to use this as our x and y. So for y it's 2. P is what we want to solve for. Tangent. C is what? C is 3 over 2. X is what? Is pi over 6. Yes. P tangent 3 times pi is 3 pi over 2 times 6 is 12. I want us to simplify this. 2 equals to P tangent 3 goes into 3 once, so it's just once, but it goes into 12 4 times, so this can be simplified to pi over 4. Okay, now what is the tangent of pi over 4? I think we can find that as well. Let's bring out our unit circle. The tangent of pi over 4. So here is pi over 4. Ne? Pi over 4 has root 2 over 2 and root 2 over 2 as coordinates. So, okay, let's use that. Pi over 4 has coordinates root 2 over 2 and root 2 over 2. right? And we know that tangent is equal to, is the same as saying y over x. And we know that this is x and y. So meaning that we can take y over x, which will be square root 2 over 2 all over square root 2 over 2, or multiplying by 2 over root 2. And when it's like this, then 2 will cancel 2, square root 2 will cancel square root 2. But they don't cancel to 0. Remember, they cancel to 1 because they are dividing into each other. So this means that tangent of pi over 4 is 1, is equal to 1. So this means that P is being multiplied by 1. Therefore, P is equal to 2. Alright? So we found the value of P. Alright. Write down the equation that defines F. Okay. So the equation is in this form. It's y is equal to P, which is 2 tangent C, which is 3 over 2 then the x there. So this is the equation. We are done with that. Now let's do 6.2. Okay. 6.2, for the function g, determine the period. Okay. So what am I doing? So G is this one, right? Is this one right here. G is this one, and it is the cosecant graph. Okay, so meaning that there is a sine graph that goes like that. Because for you to draw the cosecant graph, obviously you'll have to start by drawing the sine graph. So, as I've said before, you can take top to top, or bottom to bottom. So you can take this one minus that one to find the period, okay? So this is what? It's this point right here. It's 4 pi over 3 minus, what is this point? Is 0. Really? Yes. So 4 pi over 3 minus 0 is 4 pi over 3. So that is the period, okay? That is the period for this graph. But let's take a different point. 4 pi over 3 is the period, but let's take a different point to just put a stamp on it. Let's take top to top. This is 2 pi over 3. You can see this is the point here, 2 pi over 3. And this is minus 2 pi over 3. So 2 pi over 3 plus 2 pi over 3. It's supposed to give us 4 pi over 3. So let's see. 2 pi over 3 plus 2 pi. I can see already that this will give us 4 pi over 3, which is a confirmation. Over 3, 2 times 2 is 4. We're 4 pi over 3. Okay. So our period is 4 pi over 3. Okay. By the way, did I show you the standard graph of a cosecant function? Let me show it to you. So, okay. The standard graph a cosecant function. So cosecant is the reciprocal of it's the inverse of the sine function. Okay, so as we know, sine will start here to go up, to come to the middle, to go down, to end up where it started. So the sine graph is like that, meaning that where it touches the x-axis, that's where you draw your asymptotes. Asymptote will be here. Okay. So the other graph will go like that. To go like that. like that. And this other graph will be the cosecant graph. So that's how you draw a cosecant graph. So this is the standard form of the cosecant graph. Okay. While we keep that in mind, let's go back to the questions. We found the period. Now we need to find the value of K. And the value of K has to do with the period. Okay. So that's what we are going to look for. So we know that the period for a cosecant graph is 2 pi over K. And now we are looking for K. But we know the value of the period is 4 pi over 3. So let's write that in the space of P equal to 2 pi over K. Cross multiplying, you find that 4 pi K is equal to 6 pi. Now dividing by 4 pi on both sides, then this will cancel, pi will cancel pi. This means that K is equal to 3 over 2. We have found the value of K. 2. Okay. The phase shift B. Okay. We need to find the phase shift B. So we can see that in standard form, this cosecant graph will start, so the y-axis is the asymptote as well. It's the asymptote, so it will not touch the y-axis, right? It will go like that. Okay, so meaning that now we need to check if this graph has been shifted to the left or further to the right, and by how many units. So this is the graph. As I've said, this is the y-axis. So this graph is supposed to not touch this y-axis. It's supposed to go like that. Okay? So since it has now touched here, meaning that it has been shifted to the left. Okay? By how many units? Let's see. Pi over 3. Negative pi over 3. Can you see that? Negative pi over 3 units to the left. Yes. Because we now have this part as the asymptote. So it has been shifted negative pi over 3 units. Okay. The phase shift negative pi over 3 units. And D, let's see, the value of A, and thus, okay, so the value of A, where is A? Oh, this one right here. The value of A, that is the amplitude, right? Okay, let's go and check the amplitude. So this graph ranges between 4 and negative 4. So it moves from 0 to 4 and 0 to negative 4, meaning the amplitude is 4. Amplitude 4. Okay. E. Okay. Write down the equation that defines G. So let's write it down. So the equation has been given to us as y is equal to a cosecant k into x minus b. Now let's write it. A is what? 4 cosecant. K is 3 over 2 into x minus what is b? B is the phase shift, which is minus pi over 3. That will be now plus pi over 3. Okay, we're done with the equation. Do we have any more questions? No, we don't. So we are done with this one. See you on the next video.